Hey, I'm Jinrui Yang. My NET ID is JY2823, and this is a makeup of the first homework of DSP course. This time we got two questions also. The first one is 2.A, the ABC of 2.A, and we've been given three systems and be asked to determine if these systems are stable, causal, linear, time invariant, and memoryless. So for the first system, like here, this is the first system. The first thing we're gonna determine if it is stable or not. For this question, if it is a B in BO stable system, then for every bounded input gives rise to a bounded output. So we assume that the input xn, the module of input xn, be smaller than m. So then the output yn module of yn should be smaller than I multiply module of gn, because we don't know what gn is. If gn is bounded, then of course yn is stable, but if gn is not bounded, then yn is not stable. So that's our determines on gn. And the second, for causality, because the output only depends on the current input, yn equals gn xn, so it's causal. For linearity, we're going to check if like this. Here's the condition to check if the left-hand side is equal to right-hand side. So we can get that the left-hand side should be this term, and the right-hand side should be like this. So it's clearly that these two formulas are equal to each other, so the system is linear. And for time invariance, we should check if the system of output of x of n minus n0 equals to the output of xn, and we shift the system from on time n to time n minus n0. So the left-hand side should be gn multiply x of x minus n0, and the right-hand side should be g, because here for the gn, we also should do a time shift, so it becomes g of n minus n0 multiply x of n minus n0. So of course they're not equal, so it's not time invariant. And for the memoryless thing, this system is memoryless because the output only depends on the current input, gn and xn. For the second system, it's a collection of x of k when k equals n0 to n. The first thing is not stable because if we assume that x module xk, x of k smaller or equal than equal to or smaller than m, then we can see the output as n can be infinity, and we don't know how large it will be, so the collection will be boundless, so this system is not stable. And for causality, I first made a mistake in my mind because I think that from n0 to n, you can see that the x is always depends on the previous inputs from n0 to n, so it should be causal. But however, when we think about that, if n smaller than n0, then the situation is just like b. You can if n is smaller than n0, then the output will also depend on the future input. So it's not causal. And for linearity, the left hand side should be like this, and right hand side is like this, so they're the same thing. So the system is linear. And for time invariant, also we use the definition to get the thing that also here this is a definition thing, and to avoid the confusion, we change the n0 to q0 here, because here the condition there's a k equals n0 to n, so to avoid the confusion of this n0 and this n0, we change the n0 to q0, and here's the answer. And for right hand side, because you just shift the system from n to n minus n0, so the here should be can also be changed, so they are not the same thing, so the system is now time invariant. And for memoryless thing, the question, it's not memoryless because the output depends on the past inputs. It's a collection. And for the third system, it's just like the second one, but here it changed from n minus n0 to n to n minus n0 to n plus n0. So for this system, it is stable because the n0 will not be infinity. And for causality, because the output depends on the future thing, both past and future and current input, so the system is not causal. And for linearity, the left-hand side, you see here, is simply equal to the right-hand side, so it's linear. And for the time invariant, for if it is time invariant, we can see here, you just shift this input, and we can change this formula to this del. They're the same, and which is the same thing as the right hand side. So this system is time invariant. And last one, for it's not memoryless because output depends on the past inputs. N minus n0. That's all.